So now let's try to do the problem on the left hand side. This says this is 804 multiplied by 7. So let's try to do that. So remember, I'm going to read it from the bottom to the top. That means I'm going to multiply 7 with 4 ones. So 7 4 ones, and I want to remind you, learn tables. There's no shortcut to tables, so learn your tables. Okay, so now if I have 7 fours, I know 7 fours are 28, so I'm going to keep the 8 ones here, and I'm going to keep the 21s will get converted into 2 tens, and I'm going to save the 2 tens over here. Now 7 zeros, 7 0 tens, I'm sorry, so I should say 7 0 tens is still 0 tens, right? And then I'm going to add 2 tens to give myself 2 tens over here. So this is going to be 2 tens. And then 7 800s is going to lead to 56 hundreds. And I'm going to write this as 56 hundreds. And please note, I'm going to interpret these as 56 hundreds because this number is in the hundreds place. Okay, so that's one way to do it. This is the long multiplication algorithm. Now the problem on the right hand side is 7 multiplied by 218. I'll write it in a different form. I'll use the commutative law to write it as 218 multiplied by 7. Then I'm going to write it in the same way, 8 1 2, and I'm going to multiply it by 7. So now please note, again, 8 sevens are going to be equal to, 7 eights are going to be equal to 56. I'm going to multiply 7 with 8. 7 eights are 56. So I'm going to write the 6 ones here, and the 50 ones that are spare will get converted into 5 tens. And the 5 tens I'm going to keep over here. Now 7 multiplied by 110, so 7 110s are going to be just 7 tens. And 7 tens plus 5 tens will make 12 tens. So I'm going to write the 2 here, and the 10 tens will get converted into 100. And now I have 7 200s. So 7 200s will get converted, will be calculated to be 1400s, just like 7 2 apples. If I take 2 apples 7 times, I get 14 apples. If I take 200 7 times, I'm going to get 1400s. And 1400 plus 100 is 1500. And that I'm going to write as 15 and 1, because I'm interpreting this number as 15. You can see this number is really 1500. And then I'm going to add, this is 26, right? So this is the 26 comes right over here, and this 15 represents 1500. Exactly right. Okay. So now let's do the long division problem. So again, let's walk through them. So I have 730 and I'm going to divide among 7 children. Well, let's look at 700s. If you have 700s, just like if you have 7 chocolates and you have 7 children, well, if you have 7 chocolates and you want to give to 7 children, you can only give 1 chocolate to each child, and you'd be left with no chocolate. So now you have 3 tens over here. Well, you can't give any tens to the children because you only have 3 tens and 7 children. Like if you had 3 chocolates and have 7 children, you couldn't give a chocolate to a child. Similarly, if you have 3 tens, you can't give a 10 to a child. So we remind ourselves that we couldn't give any 10 to a child by writing a 0 over there. And now we're going to reinterpret the 3 tens as 31s, and we don't have any other ones, we just have 31s. And certainly we can give with it 31s because 4 sevens are 28, and we are left with 2 ones. So the answer would be 730 divided by 7 is equal to 104 remainder 2. Okay, so now let's do the same thing with 954 divided by 7. We have 900s and we have 7 children, so let's give 100 to each child, and we'll be left with 200s. Now we can't do much with the 200s, but we have 5 tens, so let's break up the 200s into 20 tens, and we have 5 tens also, so we have 25 tens. And now we can give three to each child. So if we give 3 tens to each child, we'll be left with we would have given away 21 tens and we'd be left with 4 tens. Can't do much with the 44 tens, but we can break them up, the 4 tens into 41s, and we can we also have an extra 4 ones, so we get 44 ones, and the 44 ones we can give 6 to each child, and we'll be left with 2 ones at the end. So what that shows is that 954 divided by 7 is equal to 136, remainder 2. Okay.